Ultra-high field magnetic resonance imaging, which includes MRI field strengths at or above 7 Tesla, allows neuroscientists to collect detailed images of very small structures in the brain. It also offers an increased sensitivity to blood flow and blood oxygenation for functional imaging studies. Compared to lower field MR imaging, ultra-high field systems offer an increased signal-to-noise ratio, better spatial resolution, and improved image contrast. In a typical MRI scan, each voxel, the 3D equivalent of a pixel, represents tens of thousands of brain cells. But ultra-high field imaging is much more precise, with each voxel covering a fraction of a millimeter, and in some cases, less than 100 brain cells. This has enabled research breakthroughs on very small brain structures and pathological features. For example, neuroscientists can now distinguish numerous subfields of the hippocampus, a key structure damaged in aging and neurodegenerative diseases such as Alzheimer's. This new data could help researchers gain a clearer understanding of how Alzheimer's affects the brain and allow them to design more targeted treatments. In one study, the 7T MRI scanner detected more than 90% of very small tumors in the pituitary gland that were not visible on a lower field scanner. Patients with such tumors, which lead to chronically elevated cortisol and Cushing's disease, can now avoid an invasive diagnostic procedure before they receive curative surgery. Ultra-high field MRI also offers increased resolution and contrast for studying blood vessels in the brain. Researchers can use the powerful scanners to collect detailed images of everything from large arteries to very small lenticular striate arteries with a diameter of less than 1 millimeter. As a result, researchers can discover small pathologies in the brain's blood vessels that would otherwise go unnoticed. This ability is critical for advancing studies of cerebrovascular disease, including stroke and cerebral small vessel disease. Another innovation powered by ultra-high field MRI is a growing body of research on perivascular spaces, fluid-filled regions surrounding the brain's blood vessels, which are involved in waste clearance. Visualization of perivascular spaces with a 7T scanner has allowed scientists to map them in greater detail and to strengthen the evidence linking them to Alzheimer's disease. In addition to these key advances in structural imaging, ultra-high field systems can more accurately detect neuronal activation across layers of the cortex and can help reveal how complex neural circuits interact in time and space. Ultra-high field offers dual benefits for arterial spin labeling perfusion MRI with increased signal-to-noise ratio and prolonged blood T1. These benefits can lead to substantially improved sensitivity and resolution of perfusion MRI at 7T, revealing fine-grained microvascular blood flow across cortical layers. With its improved blood oxygen level dependent and perfusion signals, excellent visualization of cerebral vasculature from large arteries to very small lenticular striate arteries, as well as perivascular spaces, the ultra-high field scanner can help researchers understand the physiological and functional changes in neurodegenerative diseases such as Alzheimer's by studying the link between neuronal activity, vascular architecture, blood flow, and blood oxygenation.